That tells me that you have to use before you can clear. But now, I'm slightly more confident that I'm successfully rendering to this texture. So now, let me try to, within the shader, I'll try to pass in a texture. So for example, this shader takes in coordinates from the texture and outputs that to the fragment shader. And the fragment shader does something with them. So how's this in tech chord 0? How is that even passed? And I guess I enabled the depth test as well. Blah, 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 blah. Where is that passed? Here's self.prog. Self.nvp equals self.prog at nvp. I guess you can just pull out uniforms like that. But I don't see where the texture is being passed. Self, scene ground, root nodes at 0. Mesh, vertex array object, instance. I don't get it. Where is that passed? Maybe it's in the example class? You know what it must be? And this would actually explain why this is writing to self.texture. My guess is that self.texture is a special variable. And that's why it writes to it here and then writes to it again here. And it first keeps it blank, then has it configurable with this context.texture. I sort of... At this point, I feel like a lot of the example code is just getting in the way. I don't really want this to happen in a loop like that. Okay, I'm going to try to factor this out into some code that doesn't use as much of this example code. Although I'll still have to figure out how that texture is being passed. Now getting out of that. Self.vao image.render. Oh, there's self.texture.use. Here. And then after that, it uses self.vao image.render. So that's why it's setting self.texture. Okay, this is doing a lot of weird recursive stuff. Here it's doing fbo.use, and that fbo is bound to the texture too. Then it's calling superclass render, and that render is calling texture.use. And then it's rendering. Okay. In any case, I'm gonna have to factor this out into some more straightforward code. Or code that uses less example code. I don't know if it was ModernGL or ModernGL window. that did a really straightforward example. I think this is all I need. And don't I actually already have this code somewhere? No, I guess I don't. Oh no, modern.gl rendering.py. Well, that's a nice array. Why did that take so long? It's rendering with image magic. Okay, so here I had this print the vertices. Then it calls this image.fromBytes whatever, and it calls .show. Okay, that's fine. I'm gonna copy this data into there. So basically the program and the vertices. There's a program, there's the vertices, and the indices actually. I'm gonna see how much I can get away with copying here or pasting here. So now the context, I'll actually still need. So that I'll keep. The program I want to replace with this. Okay, the program is a context.program. Great. The data vertices is going to be this. And the indices. So now the vertex buffer object is this. There's no self.context. Then the vertex array object is this simple array. dtype.names, that's fine. And then index buffer object, which I guess I need to do that. Okay, after that, oh, there's no self. Frame buffer object, use the frame buffer object, clear it, render it. Okay, so now let me get rid of all of this. Run the modern.gl rendering script. It's black again. Oh wait, that makes sense, because I cleared it with a black color. So that makes sense. I should default that to a floating window. Cool. So now this isn't happening in a loop. All of the logic is right here. So now the question is, can I render to a texture? And the answer is, of course I can't. Well, here's one reason why render to a texture might be easier now. Close this. Now, I don't even have to use the same shader to render these two. Which would actually make sense with the text rendering example, because in that one I won't have the same shader. So let me look back at how you can render to a texture. It's basically this code. So that's doing that render. And I'm gonna try... I'm going to render this hourglass shape, and then just render over it. So if I clear to black and render again, now I would expect to see just a black image. Shift. I wasn't trying to do that. How did... New window manager, okay? Okay. So now I expect this to be a black image. And the reason this is a black image, because I rendered the white image, then I rendered over it. FBO.clear. I'm using this frame buffer object. And this frame buffer object is, I don't know, derived from the context. So here's a question. If I make a second frame buffer object, which is smaller, half the size, of the first one, and I render the large one in white, then the small one in black, what would I see here? Okay, I don't see the small one at all. Oh, maybe I have to use it. So it's use, then clear, then render. No, and I still don't see it. Darn. I would have hoped that would appear on the screen somewhere. Is this what I want? The same program? Yeah. Vertex buffer, same vertices, yeah, same vertices names. Okay. So now the question is, what if I only use the second one, the black one, which is half the size? FBO is not defined. What? Line 67. Oh! I'm only showing the one from FBO.size. Wait, RGB, FBO.size, FBO.read. So it's only reading from FBO. If I wanted to see FBO2, I'd have to put it... You have to do like this? So this will show the black one, which is also smaller. How can I show the black one on top of the white one? Okay, let's render to the FBO and render to FBO2. Let's read FBO size bytes and read from FBO2. Not enough image data. Okay, so I guess the data has to be aligned correctly. I know I can have multiple vertex array objects, right? Maybe what I'd want, if I want to render a smaller image, is to just create another vertex array object. After all, in this example, it took all of these different vertex array objects and rendered them over each other. Rendered them like one after the other. Although I have no idea what this means. Like self-seen ground, root nodes, mesh, vertex array object. But I'm gonna try doing that. VAO, and here's a VAO too. That's the same program. The vertices... Maybe I just like divide them all by half. Divide them all by 2. Assuming that even does what I think it does. Actually, I don't think it does what I expect it to do. You just make the vertex buffer object here, the index buffer object there. And now I'm just gonna do this again. And just divide all of these by 2. That'll be the same. Now I have a VAO2. I'll use the same frame buffer object, I guess. And maybe now I can just render this on top of it? Maybe? Wait, yeah, VAO2, then VAO2.render. How is the frame buffer object related to this? I guess I use that. I use the frame buffer object, then render with the vertex array objects. Okay. Don't know what this is gonna do. It's only the white one. That's annoying. Although maybe that has to do with the blend function? I'm gonna try not rendering to the first vertex array object. So I'm gonna move this back. This vertex array object, just don't render to that one. Only render with this one. Let's see what this does. Okay, now I do see the smaller hourglass. Maybe what the problem is that this hourglass was just exactly overlaid with the other hourglass. And so you couldn't tell if one was on top. I would just give it a different color. Okay, here's what I'm gonna do. Actually, why don't I just give this a uniform? We have a uniform vec for F color. I'll just call it color. Then this can just be color. And now, before each render, so here's a render. I'll do prog dot prog at color. And this can have that default color, which I forgot. And I deleted. This color. And here, for doing the VAO2, I can make this just red. Okay. Great, so that's red. Now if I render the large hourglass and the small hourglass. Okay, this is what I expected. So I can overlay the two of them. Which is great. Man, I ended up doing this for a long time. So I'm going to delineate these more clearly. It's going to be under the large hourglass. Time flies when you're having fun. Exactly. Okay, so what I want to do is render the hourglass I think I want to render the large hourglass, render the small hourglass to a texture, and then render the texture onto the screen. So I'm already rendering the small hourglass. The question is, how do I render the small hourglass to a texture? Actually, I have to split this up more, or I'll get too confused. Doesn't have to be a lot. Where's it getting this? Context? Where's it getting the context? Is it just reading this? Okay. Okay, this. Then I can say render large hourglass, and right after that, render the small one. This should do the same thing. Great. So now I can actually see what happens if I render the small one first. And here, I think I won't see the small one. Yeah, because the large one was rendered on top of it. Okay. So, how do you render to a texture? I guess you do this. Depth attachment. The size is just this. So I can put size there. Oh, these are the same lines that were already there. Let me just make sure that I didn't break anything. Great. Alright, let's get this texture. Do context.texture, size. I don't know what this 3 is. I guess that was the number of components. Sure. Depth attachment. Is that? Don't know what that is. And a second frame buffer object. Do I need a second one? This only has one frame buffer object. One frame buffer object, which is the size of the window. And when it's rendering to the texture... Wait, there's no way this has one frame buffer object. Self.context.screen. It has this one, which is called FBO. Then it has self.context.screen, which I don't know what that is, actually. But the fact that it's calling use on it makes me think it's a separate frame buffer object. So I'm going to assume there's two of them. So there's the texture, there's the depth attachment. I'm going to call this the texture FBO. Oh, this one was a simple frame buffer. This is a non-simple frame buffer. But great, now I have a second frame buffer object. So, what do you even do with a frame buffer object? You use it, and after you can use it and clear it, and after you use it, any subsequent render will write to that frame buffer object. So I'm going to render the large hourglass, render the small hourglass, use this frame buffer object. Yeah. So clear this to black. Wait. So this is black. Clear this to black. Use it, which I don't know if that'll work, because I think you have to use it and then clear it. And then render the small hourglass again. But now that I've used this texture frame buffer object, I think the render of the small hourglass will go onto this texture. Or maybe not. It takes one positional argument. Wait, oh. Great. So I rendered the large one, rendered the small one, then rendered the small one to the texture. The next question is, can I do another render which writes the texture to the screen? The first frame buffer object. I don't even know how you pass the texture to the shader. But this, when it's rendering to the texture, all it does is clear, use, and then render.